Good morning students. Today is the 27th class on digital land surveying and mapping. Today I will be talking on errors and quality of measurement in surveying. Now this class will be discussed under following heads. Introduction followed by what are the different types, what is error in measurement, what are the different types of errors in measurement. Of this we will discuss at length about the estimation of random error and followed by quality of measurement and weight of measurements. If we make a measurement of a parameter repeated number of times, now we will see that every repetition may not give you or give us the same value. Rather we will see and we find that if we repeat the measurement of any parameter number of times, we do find measurements having different values. This clearly indicates that there is some errors that is associated with the observation or the measurements. So we can very well say that most of the measurements are associated with errors. Also, how much error it is, we need to test it by looking into its true value or exact value, and then only we should know what is the quality of the measurement. The quality of surveying work depends on the quality of the measurement, means what is the amount of error associated with the measurements that define the quality of the measurement. So to improve the quality of the measurement as well as quality of the surveying work, we need to have our measurements free from errors or to have error in minimum extent, and for that reason we need to know what are the different types of errors, how these errors are associated with it, and how these error can be eliminated or minimized from this measurement. So and based on that only we will say that what is the quality or reliability of the measurement. Actually now first we have to know what really error is. Now if we know, suppose we want to find out the parameter, we want to measure x. Now suppose the true value of the parameter is xt or t, and if we observe the parameter as xi then or x, then the difference between xi and xt, or we can say x minus t, is our error. So the observed value minus observed value minus true value provides us the error in measurement. Error in measurement. Now in many literature we do define error by the word correction, which is the opposite of error. That means if we subtract the observed value from true value, then we will get the correction. So sometimes we define error in terms of true value minus observed value, that means that is actually the correction. That means true value minus observed value, whatever it is, that we should apply directly. We can apply directly to observed value to obtain to get true value. So this is what is the background behind error and its measurement. and how to make the adjustment for the error. So, but now one point is that which is important, before we go further about the error, we need to know the types of errors. There are different types of error. In any measurement there will be three types of error. One is that called gross error, and next one is systematic error, and the third one is random error. Now the gross error, actually it is these are the mistakes, and these are very big in value. So in any measurement, if we take a set of measurements and if we observe the set of measurements, we will find that some of the measurements are very different from the most of the measurements, and those measurements we can very well say that are having the gross error. So what we do, we generally eliminate those errors, those measurements from our computation. So gross errors are broadly the mistakes. Already we have discussed about this with reference to total station. I have discussed many of the gross errors that we do come across, and how to overcome those gross errors also we have discussed. Now the systematic error, the name itself tells systematic errors are the errors which are associated with the system. So last few classes I had discussed at length about the different systematic errors that are associated with the total stations, as well as previously we had discussed a lot of systematic errors that is associated with the GPS measurement. So these systematic errors can be physically modeled and has to be taken out from the measurements. So and this is also taken out through physical model. So whenever we have some observation x, we will take out the suppose we have a set of measurement x. First we will remove suppose x n. So we will take x m value, and m is less than n. So m n minus m, these numbers of measurements having gross errors. So these numbers of measurements, we have found that out of the n numbers of measurement, n minus m number of measurement, we can say m measurements are more or less similar, but n minus m numbers of measurement will be having a lots of variation. So those have been taken out. So we have left with xm number of measurement. Now out of this, from xm measurements, rather I should write in a matrix form, n into 1, m into 1. So from m into 1 we will remove the systematic error. So we will get a measurement having some systematic error. Now this measurement will be having another type of error, that is called random error. Now this random error, by the name itself we can see that it is random in nature. So we does not follow any definite rule or law. So we have to take out the random error from the measurements by using some statistical analysis. So we do make use of statistical analysis to eliminate or to minimize the random error from the observation. Now, so random errors are the eliminated and systematic errors are corrected, and so associated with random only, and this error is small and equally liable to be plus or minus, thus partly compensating in nature. Random errors are unpredictable and they cannot be evaluated for quantified exactly. So, this is what is the random error. Now, so as I told you that random errors are determined by using the statistical analysis. We have some assumption about the random error. First assumption is that random errors are very small in value, and small in value, and they varies little around their mean values, and also they are maybe either positive or negative. That means it may be more than the mean value or it may be the less than the mean value. So, positive and negative variations of the same size about equal in frequency, rendering, and the number of measurements having positive random error and number of measurements having negative random error is assumed to be of equal in number and have the symmetrical distribution about the mean value. So, this is the assumptions on which we do this, and then we this assumptions satisfy that the random error are normally distributed. That means if we say this is the mean of the observation, then the random error, and if we say the frequency, this is the positive values, positive negative values, and the frequency will be like this. So, we can say that the random errors are distributed symmetrically about the mean and also positive and negative direction. So, this is the concept that random error are normally distributed about its mean value of the observations. So, as it is written that random error is measurement eliminated by taking observations for repeated number of times. Normal or Gaussian distribution typifies the spread of samples in the measurement. So, these are the samples, or this is the frequency and maximum frequency at the mean, and gradually it will be reducing towards both positive and negative direction. So, this is what is the assumptions we do during analysis of random errors present in measurement. Now, how to estimate the random error? To estimate the as the random error is assumed to be normally distributed. So, we do make use of the concept of normal distribution in finding out the random error. As we have told that the error is equal to our observed value minus true value. Now, there is this is a very ambiguous term. What do you mean by true value of a parameter? Actually, different ways it can be explained or implemented. Generally, whenever we will measure a parameter, suppose we want to measure the distance between 2 points. So, what is the distance between? So, what will be the true value of this? So, one school of thought, or sometimes what we do, suppose we want to measure the distance between 2 points with a scale having a least count 1 millimeter, 0.1 millimeter. Then the true distance of this will be considered if we take a scale having least count less than 0.1 millimeter. So, if we measure the distance using a scale whose least count is less than 0.1 millimeter, we will get a value, and that value may be least count less than 0.1 millimeter, and this value can be considered as true value for measuring the distance with a scale having least count greater than 0.1 millimeter. So, this is one school of thought. Another school of thought is that we can find out the most probable value of a set of measurements. Suppose we do not have any scale or having least count 0.1 millimeter. So, and we will be using a scale having least count 0.1 millimeter only. We do not have less than that. So, what we will do? We will take a set of measurements. We will take a set of measurements using a scale having least count 1 millimeter, and then we will apply the method of least square estimation method. So, least square estimation method provides us a value which is considered to be the true value, or estimated true value, So, this is what is estimated least square. Now we have another point, least square estimation method. What is that? Now, least square estimation method assumes that the value for which sum of the square of the errors, let us say value, suppose x bar is the true value. Now, if we take x bar minus xi, observed value, sum of the I equal to 1 to n, suppose we have taken n numbers of observations, sum of the square of the error, this is the error. So, because if we take square, whether actually it should be error is x bar minus xi, xi minus x bar. So, whether it is xi minus x bar or x bar minus xi, hardly it will matter because it is a square. So, xi minus x bar, sum of the square of the error minimum is minimum. So, this is what is called least square method. Then in this case, for the value for which this is minimum, for that value is called the true value, or in statistical term that is called most probable value. Most probable value, and most probable value also, that is what is considered to be the estimated true value. So, estimated true value. So, by least square method of analysis, least square estimation method, we can find out the most probable value, and this most probable value is considered to be the estimated true value. This is what is our concept behind measurement or finding out the most probable value. Now, if we find out the most probable value, then for further observation we can find out, if we know, then this will give the error for xi dash, many other observations other than xi. So, that is what is written here. Random error is estimated using the least square method of analysis based on most probable value. So, this is the most probable value which can be determined by least square estimation method. What is that estimation method? It says that the sum of the square of the error, this is the error square sum of the square of the error is minimum. Now for this underlying assumptions, now in order to find out this, we have to do some assumptions. Least square method of analysis or estimation has some assumptions like that observation contain random errors only. That means this contains only random errors. That means systematic error and gross error has been taken out from original observation. Small errors, that means now you see this is the most probable value mu or x bar I have written here, so I should write it now. It is x bar, or we can write it mu, So small errors have higher probability of occurrence. Now you can see here whatever is the observation frequency is more here, frequency is less here. So the probability of occurrence of small error is more. That means frequency is more, and the number of observation is large. And the most probable value is considered to be the estimated true value. Now if x is the observed measurement, p is the most probable value, then actually this measured value xi minus mu, that is called residuals. Residuals are nothing but random errors. So now in this diagram, we can show you with this diagram. Now you can see here that the measurements are frequency versus measurement value, and you can see this is the maximum frequency and this is the mean value. In case of normal distribution, we will find that at the maximum frequency we will have the at the mean value. Now suppose the di base, this is the true value, then this difference true value minus the mean value, that is the average error. Now suppose for any measurement, this one di is the measured value, so from that the ei will be the true error, whereas the vi will be the residuals, because residuals will be computed from the most probable value, which is d. So short, this diagram is like this, and this is now quality of measurement. Now because as I told you, the quality of surveying measurement depends on the amount of errors associated with it. Now what is the amount of error, what is the nature of the error? This has to be indicated. Now there are parameters like accuracy, precision, relative precision and weight. These are the parameters which actually defines the quality of measurement. Already I had discussed about accuracy. Actually accuracy provides us the overall estimate of errors present in the measurement. So accuracy should be very high. Precision only represents the random error present in the measurement. So once the systematic and gross errors has been taken out, then only we can talk about precision, and precision should be good, and relative precision is the ratio of the precision of the given measurement divided by the value of the measurement itself. So it is also a kind of precision, but this will give us the comparison between two measurements and what is the relative precision. And another the relative precision and the weight of a measurement is taken is inversely proportional to the standard error. These are the two parameters, relative precision and weight, which represents the reliability of the measurement. And we can compare two things also using this. Now what is standard error? Actually standard error is used to compare the quality of the, or to define the amount of accuracy or precision. Standard error is given by your summation of, I should say, mu minus xi whole square I equal to 1 to n divided by n minus 1 square root. This is the standard error plus minus. So, from this most probable value, what is the deviation of the observed value, square of that gives the standard error. And another parameter, this is the standard error actually associated with a single measurement. Now, if we want to know what is the standard error of the whole set of measurement, then we had to find out the standard error of the most probable value, and that is given by Sx by square root of n, when n is the number of observation. So, this is the standard error associated with most probable value. That means it decides about the set of measurements together. So, if we have a one set of measurement, another set of measurement, if we want to compare between that, then we should go for Sx bar. But if we have a set of measurement here, and if we want to compare among this measurement, then we should go for Sx. So, this is what is about this. And another important thing, now what is the reliability or what is the chance, that is given by the by a factor. Standard error of most probable value, as I told you, indicates the chance of that the true value of the measurements lie within a certain range of the sample mean. It is an indicator of reliability of measurement. Suppose a measurement lies within this, from this point to this point. So, this is I can see 0.6747 sigma. If we say maintain a range, this one, within that range if I get a measurement, then I will be able to say that this measurement will have 50% chance to become the true value, or we can say other way, that the uncertainty of this measurement is 50%. Now, if we take a range between mu plus sigma and mu minus sigma, then mu plus sigma and mu minus sigma, if I take a range between these, and if a measurement falls within this range, then we will say that the measurement is having a chance to become true value of 68.5%. So, and other way we say that the uncertainty of the measurement is 68.5%. So, in that way we may define different ranges to find out the degree of uncertainty associated with the measurement or the reliability of the measurement. Uncertainty also defines the reliability of the measurement. So, with this I like to conclude this class. Now, I like to summarize that a physical parameter is represented by its measurement, by making a measurement. Like if we want to say the distance between 2 points, it is a physical thing, distance between, and we do measure the distance, that is the measurement. And most of the measurements are fraught with errors, and these errors may be gross error, systematic error and random error. And gross error and systematic error we can take out quite comfortably easily, and once it is done, then we should look into the random error associated with the measurements. And we find that random error in the measurement is very random in nature, so does not follow any mathematical rule. So, we go by statistical method of analysis. The quality of a set of measurement is actually defined by its accuracy, precision and relative precision, and the precision refers to the behavior of random errors, and we generally make use of standard error to define all these precision, accuracy and relative precision as well as weight. Worthiness of the observed or computed value of the measurement can be tested by using standard error and indicator for measurement of reliability. With this, I like to conclude today's class, and in the next class I will like to discuss how this error gets propagated in our computed value, because we have now discussed about the measured value. Now we will go for computed value. In surveying we will go for computation. So we will I like to discuss how the measured error in measurements propagate to the computed value. Thank you.